Hello guys, this is Harish and team going to present about securing your data with code. First, introduction to encryption and decryption in Python. Second, symmetric encryption in Python. Third, asymmetric encryption in Python. Fourth, hashing in Python. Fifth, salting and key stretching in Python. Sixth, conclusion. First, introduction to encryption and decryption in Python. Encryption and decryption are two important concepts in the field of computer security. Encryption is the process of converting plain text into ciphertext, which is unreadable without a secret key. Decryption, on the other hand, is the process of converting ciphertext back into plain text using the same secret key. Python is a powerful programming language that can be used for encryption and decryption. In this presentation, we will explore how to use Python to encrypt and decrypt data and discuss some common encryption algorithms. Second, symmetric encryption in Python. Symmetric encryption is a type of encryption where the same key is used for both encryption and decryption. One of the most popular symmetric encryption algorithm is the advanced encryption standard, which is widely used to protect sensitive information. In Python, we can use the PyCrypto library to implement symmetric encryption and decryption using AES. We first generate a random key, then use the key to encrypt the data. To decrypt the data, we simply use the same key to reverse the encryption process. Third, asymmetric encryption in Python. Asymmetric encryption, also known as public key encryption, uses two different keys for encryption and decryption. The public key is used for encryption while the private key is used for decryption. This allows for a secure communication between parties without the need for a shared secret key. In Python, we can use the PyCrypto library to implement asymmetric encryption and decryption using the RSA algorithm. We first generate a public and private key pair, then use the public key to encrypt the data. To decrypt the data, we use the private key to reverse the encryption process.
Hello guys, this is Manoj here to explain hashing in Python. Hashing is one of a way function that takes an input or message and produces a fixed size string of characters called a hash value or message digest. Hashing is commonly used to verify the integrity of data as any change of the original data will result in a different hash value. In Python, we can use the hashlib library to implement hashing using various algorithms such as SHA-256 and MD5. We simplify pass the input data into the chosen algorithms function and receive the hash value as output. Salting and key stretching in Python. Salting is the process of adding a random string of characters to the input data before hashing to prevent attackers from using pre-computed hash tables to crack passwords. Key stretching is the process of applying multiple rounds of hashing to further increase the difficulty of cracking passwords. In Python, we can use the bcrypt library to implement salting and key stretching. Bcrypt uses a modified version of the blowfish encryption algorithm and automatically generates a salt when hashing data. It also supports key stretching by allowing us to specify the number of rounds of hashing to apply. And here is the conclusion. Encryption and decryptions are essential tools in the world of cybersecurity, and Python provides us with powerful libraries to implement these processes. Whether we need to protect sensitive data or ensure the integrity of messages, Python has us covered. By understanding the concept of symmetric and asymmetric encryption, hashing and salting key stretching, we can create robust and secure systems that keep our data safe from praying eyes. And next, Shivaraj is here to explain the code.
So guys, coming to the coding part, we're gonna use Visual Studios to code the entire process. And first we're gonna import a module called TakeInter, which provides us a usability of graphical user interface. And after that we're gonna declare a class called substitution cipher, and in this class we're gonna declare three functions. And the first one is called the default function in it, and in that function we're gonna declare all the variables, that is the alphabets we're gonna use for encrypting and decrypting. And the next function is encrypt function, and in that we're gonna use argument of self and plain text. The plain text is the one you're going to input. And in this encryption function we're going to use the simple ciphering process to encrypt the given text to ciphered code. And next up is the decryption function decrypt function, and in that we're going to use the ciphered text. We're going to convert the ciphered text back to our plain text, and we're going to use a specific key called key to use the encryption and decryption option. Then coming to the graphic part, we're gonna create a class called app, and in this we are gonna create a window or room. We're gonna split the windows into columns and rows, and we're gonna place widgets and labels. Place the widgets on the appropriate positions and going to label each and every widgets. That is, we're going to give a widget for encryption, decryption, and the go to option. And at last we are going to declare the app as root, and we're going to do a main loop of a thing at the end. That's and while running this program here. So as an example, let's give a text of Guna in the text part, and when we encrypt this we get a ciphered code. And when we copy this code and ask the system to decrypt it, we get our text back. So this is the project, and thank you all for listening. Thank you.